Hello and welcome to the next Nix Hour. As always, if you have a question beforehand you want to ask, you can open an issue in the Nix Hour repository or upvote existing issues, and we'll try to prefer these. But of course, if you're joining the meeting, that takes preference. This time we don't have any questions in the meeting, so I'll go through something from here. So we have one of the first issue here. We looked at this before already. I should maybe close this one and talk about things as they come up. The Nixos testing library, we also talked about this before. And a separate issue has been opened, which has been addressed. So actually, I should close this one too. So we are kind of running low on issues, and I encourage everybody to open more so we have things to talk about or join the meeting. All right, but other than that, well, this is also, I do not know a lot about this or how to exactly go about this. Might be a future Nix Hour, but this one looks interesting. I know about this and can talk about it. So we have a question from Simon about knowing more about Nixos modules and how it can both define and take a config properties. And his questions: how can config CFG refer to the global config, which is itself partly defined in this file? How is config built up, or how are modules combined? And common causes of infinite recursion. Yeah, and then a bit of discussion about this. So yeah, I think that sounds great. Let's go in this. And I think maybe a good way to go about this is to kind of build this up from a very small example. Let me go Nix Hour modules. All right. And let's write a default.nix. So maybe we just start off with, and I think we might have even ended on this in the last Nix Hour, with fixed points. So let me import lib here. Lib equals import Nix packages lib. And now we have the lib.fix function, which can turn a function that's self-recursive into the, well, it calls a function with the evaluated result itself. So we can do things like, we can say A equals 0, B equals, or let's say F dot, well, this is not a function, this is the result, so let's call it X, or address dot A plus 1. And now we can do Nix instantiate eval dash A B. And it results in 1. So that works. And maybe how can we transition to this to something like the module system? Let's maybe write like a very, hello everybody. Let's write like a very simple module eval function, or actually in Nix packages it's called eval modules. Well, let's not confuse it. Let's make it prime. And so how generally it works is we take a list of modules. So let's do this here, list, and then let me think. All of them have a fixed point. Ooh, this might be pretty tricky actually. Could maybe use it with overlays, would also not be entirely right. So, well, list of functions. So the module system are essentially, every module is essentially a function like this. It's a fixed point where, let's see, let's just try something like this. We do a let in, oh, this indentation is a bit annoying. So list of functions, let's say we have final result, that's X. And let's say we merge all of the functions together, or the result of all of the functions. Let's do this very simply for now. Let's use a recursive what is it called? Recursive update, I believe. Yeah, and so we need to combine multiple. Let's use a fold here. So we have an accumulator, an element. By default, I write folds like this at first, where we just propagate the accumulator. It's kind of easy to see the structure like this. So we use recursive update. We want to use this in here, let the recursive update. And now we could do it like this, but now we can reduce the, I think that's error reduction in functional programming terms. We can do it like this. And now the result of functions. And now we need to actually define the result of functions. So we do result of functions equals, so we map over the list of functions. And for each of the function, we call the function with x. Something like this might work. This is the final result. And let's put this here. Final result. All right, and so let's just also compare this to lib.fix. So let's do this, let's move this one up here. It's called a simple fixed point. And let's also write the implementation of fix. So fix is equal to let x, so we take an f, let x, well, you can write it down here, equals fx in x. This is how fix is defined. And now this is a bit similar in how we have this final result here. This is, well, it's also called this x for symmetry. This is the x, but instead of just calling a single f, we call a whole list of functions. And then we combine the result of each of those. So let's see if this works. To do this, we need a list of modules. So, well, modules are fixed points. So let's start with, in one of them, we're going to do a equals 10. And in another one, we're going to do b equals 20. And then let's also use a third one. And let's put this up here. C equals x dot a plus x dot b. Now, this is the first time I wrote this, so I'm not confident if it actually works. Oh, but that, so we have A, C also works. Okay, that turned out pretty good, actually. And so this is, we can kind of think of this as a very, very simple form of the module system. And in reality, there's more things than just this argument here. And we can also model this in here. Let's make this a bit more extensive. So instead of taking x here, we want to take a config here, kind of modeling the module system here. So let's change this already. And so now instead of just taking the final result, it takes the final result but wrapped in this attribute set under config. So we change this in here, config equals x, the final result. And now this should again work. Oh, no, we need to actually update this here. All right, that still works. We can evaluate C. And now, but let's also do the same thing that the module system does. Well, in the module system, if you use a form like this, it gets automatically changed, or internally, it's the same as this. Let's mirror this here. So also config equals indent, and close. All right, and to do this, so we evaluate the function, we get back a result, and then we want to take only the config from that result. And so we can do this using this, I believe. So just call the function and then access the .config attribute. And let's try this again. Yep, still works. Okay, and so this is much closer, but now we can also kind of see how this config attribute is different when you define it and when you access it. And so the difference here is that this is just a local definition of this config attribute, but this config contains all of the final attributes can merge together. And there's no reason these need to be called the same. So you can see in here, we added this in 2 steps. We added config equals here, that's for the argument here, and the .config for the result. But we might as well just say local config, and here this is the global config. And then we could adequately change this here. And honestly, this has been suggested as an improvement, or something like this has been suggested as an improvement, because config has been confusing a lot of people.
It's the other way around.
Argument,
you said argument local config.
Oh yeah, thanks.
Screen share just stopped. And now you're on mute.
Oh man, Jitsi being a bit annoying today. But yeah, I changed it. So global config and local config here. We can change this as needed in our in our toy module system here. Yeah, so this is pretty much, I hope this explains it fairly well. Let's see, let's look at the other questions here. Right. Well, how does this work in the end? Just to explain this a bit more, this works because of laziness. And so in Nix, when you do a left binding, Nix doesn't immediately evaluate these values here. It creates a thunk, which is just it just points to this computation essentially, but doesn't evaluate it yet. And so evaluation happens on demand. Only once you evaluate something, it actually needs to be done. And yeah, this is what allows us to define X later here, but uses in the first function, and how the first definition here also uses the first one uses X, and the second one uses, it's recursive. We have this refers to, this is being referred to here, and X is being referred to here. Yeah. So, oh yeah, and then how is config built up? How are modules combined? So yeah, in this case, we did it very, very simply here, and this will cause problems. So let's now try to break this here. Let's do, what if we do a equals 30? Well, let's do 40 here. That didn't change anything. But what if we do a equals 40 here? That changed it. So because lib.recursive update doesn't really, well, we do it in this particular order. We do it from left to right. We do recursive update. And so later values define earlier ones. So here we can see the A from down here overrode this one. But in the module system, we want something smarter, something that can tell us when conflicts happen, something that allows us to override values with, well, explicitly override them or explicitly not override them. And to do this, we could maybe, could we implement a simple type merging? Or maybe, so let's go into Nix packages and see what there is for merging. So if your Nix packages here in lib, there's 3 main files where the module system is defined. The main one is modules.nix. Then we also, main one. Then we also have types.nix. That's where all the types are defined. And then we have options.nix. That's where the kind of auxiliary functions for options are defined, I'd say. And so if you go in here, I want to find, we have isOption, we have makeOption. This is commonly used. What I want to find is the some merging operations. And these are defined in here. So we have a merge default option. This, I don't recommend using this. Well, all of these shouldn't be needed by default. These are generally used by option type definitions. And so the one I want to find here is this one, merge equal option. This is probably one of the most used merging operations. It's used for kind of all of the primitive types. So this is used for like ints, strings, types.string. It's used for floats, for booleans, and so on. And so what it does is it, this is needs a bit more background here. These functions are always called with at least one definition. So, and this is guaranteed by the modules.nix file. So when you don't have any definitions, then it's just going to abort and say that this shouldn't happen. But otherwise, we have very simple, if there's only one definition, if length def equals 1, it takes that definition. So let's also briefly explain the API here, how it works. We have LOC is a list of strings. This is how the module system knows which option you're referring to. And so this is, for example, environment.sys. Well, it's like this. Environment, and then system packages. So this is for the functions here to be able to throw a better error message. And so we can see this down here, the option, then show option of LOC. LOC stands for line of code, I believe. And then we also have the defs. And defs is a list of value, and value is kind of anything, and a file. This is a string. This allows the module system to know where the definition occurred, so it can also throw a better error message, which is used down here. But yeah, so this is a very simple merging function. It takes the first value if there's only one. Otherwise, it checks for all of the values to be the same. If there's two values that are not the same, it's going to throw an error. Otherwise, it's just going to merge it as the one value that is there. And yeah, we can replicate this in our own module system here. So let's replace this merging function with something like that instead. Actually, we might as well. Let's do it. Let's do it manually here. So we don't have an LOC. Let's also not worry about where the options occur here. Let's just do defs. Well, let's do a merge equals defs. So we take all of the definitions. We check if, we might as well do this. Fold L, we take, let me again do this. Accumulator element, and then return the accumulator. We say, let's do the head of defs. So the first definition, that's our kind of default. And then the rest, we could use tail of defs here. So something to know about lists in Nix is that they are arrays. They're not like Haskell lists. And so tail needs to actually create an entirely new list, but with one element less. And so the complexity of tail is O n. And so this can get expensive if you call tail in a loop, it could easily turn into n squared. It's just something to watch out for. Here we can use it, well, we could also just use defs here, but let me use tail. So now we have the accumulator here, that's the kind of previous element. The element is the new one we are gonna take a look at. Now to write this, we wanna do a comparison here like we saw earlier. If ac is not equals to L, then we're gonna throw an error. And we can throw conflicting definitions. Else, we're gonna return ac or L. It's the same thing at that point. All right, so we have a simple merge function. Now, we don't have an error message here. And so we would need to, what would we need to do? We'd need the LOC here to get the error message. And well, let's just call it name here. Conflicting definitions for attribute name. All right, and now instead of this merging function, we're gonna do this. We're gonna say x equals result of functions. We're gonna do, this is now a list of attribute sets. So we can't just call this directly here because we don't map over individual attributes yet. Let me think for a second. Oh yeah, this is a bit trickier actually. So we need to, what we need to do is kind of destructure, well, not destructure. Let's do it like this. So we have attributes, or let's call it all the names. I'm just writing a lot of Nix code here actually. So all the names, we're gonna do a concat map. And we're going to take all of the results and we're going to do a lib.attribute names as a result of functions. All right, and now we're also going to do lib.unique. And we can shorten this to just this here. So we have, these are all the names that are defined in all of the local configs here. And now we can map over those. So we can say, oh, I'm struggling a bit here. Let's do a map address, lib.map address, name, value for now. All the names, actually this is not right. We need a gen address. I believe the order is different for this, yes. I believe there's probably a better way to do it, but I'll go for it like this for now. So gen address, we take all the names for each of the name. Let's get the matching ones or the values. So all of the values are lib.filter, yes, result of functions. We're going to filter out all of the results that have the attribute, like this, or matching results. And then we're going to do results or values equals lib.map, and then result.name. Result of functions. Oh, matching results. All right, and so yeah, that should work. So we have all the values, and now we can actually call the merge function. Merge, and we know the name here, and the values. All right, I believe that should work. Let's try it out. So it turns out it's not that easy to do. Maybe there's a better way, but let's try it. Undefined variable head, that's here. We need lib.head, lib.tail. All right, attribute map missing. Yeah, that's really weird. I do not like this, but lib.map doesn't exist. Conflicting definitions for attribute A. Awesome. So it worked. And we cannot see where the conflict occurs. That would be even a more advanced feature where we'd have to kind of. So the module system has, well, an internal file thing you can use here to indicate the file, or if you import something by path, then it already knows about the file. But yeah, so we can remove this here again. Now we should get the result we want again. Yeah, so this is a simple merge function. It has a lot of restrictions still, so it can't do anything recursively. If we were to do, so let's say in attributes here, let's say x equals 10 here, and then attributes equals y equals 10 here. This wouldn't work. Well, if we were to evaluate attributes, it wouldn't work. Conflicting definitions for attribute attributes. So it doesn't know about how it could recurse into these attribute sets. That's something the normal module system does. But yeah, that comes then with a lot more explicitly. Yes, exactly. So comment about, yeah, we need like 1,000 different types and merge functions and features to get the module system. And I think this might be a good place to mention. It's actually not discussed. Yeah, so Robert Hensing actually, I haven't checked this out a lot myself, but he wrote a kind of simple module system alternative, which is restricted in many ways, with the hope of improving speed and maybe using it for more things than just the NixOS, and well, just making it possible to use for a lot more extensive things. There's some basic feature included. There's a lot of things not included. A lot of these aren't strictly necessary, though, to get the useful things. And yeah, it's not that difficult here. It's like 300 lines of code. And so this would be kind of a middle ground between the this ad hoc module system we created here and the full one, which spans, it's modules.nix is over 1,000 lines. Yeah, I think this was linked somewhere, but yeah, you can, well, it's kind of hard to type this, but you can find it here. Another question we had, common causes of infinite recursion. For this, yeah, I know some things. So let's try infinity, and let's write a module system, an actual module now, a Nix's module. We're gonna use config and yeah, let's use config here. And so one of the a very common thing I see is where imports depends on config. So we might add this can easily occur when you might have a config up here. So config equals config.services.openssl.enable like this, and then maybe imports equals something plus config dot or lib dot make optional. What is it called? Optional. Yes. Config dot enable, and then if that's included, you do an import of some module.nix. And so this, I believe, even if the file doesn't exist and it doesn't really make a lot of sense, this will already throw an error message. So let's try it. We're going to just do a Nixos evaluation like this, pass the configuration, that's infinity.nix, and -a system. Oh, and let's get rid of the eval here. We don't need this. Like this. Oh, lib isn't defined. Fair enough. Let's add it. And yeah, we get an infinite recursion. And so this kind of fundamentally doesn't work in the module system. You can't have imports depend on config in any way. And that's because, in essence, the module system happens in 3 main phases. The first one is, well, it's not entirely phases, but you can think of it that way, and generally that's accurate. We have the first phase is resolving imports. And so this happens recursively. So the module system looks at all of the imports in the kind of root module or the list of root modules. And for each of those imports, it does this recursively as well. So you kind of build a tree of modules that are included, and in the end, they get flattened to a list. So let's do recursively. And then the next step is merging and merging and discovering options. So then it looks at all of the options here. So yeah, at the options of all of the modules. So after it has this list of flat modules that are imported, it looks at all of the options attributes to figure out what options are available. And also it merges the options. So merging options, yes. And finally, merging, I guess, and also discovering, let's do merging of config. And so config is then the final, and that's where most people, where most user level modules define things. This is where your environment.system packages is defined. And this, to make the example a bit more complete, here's where the option is defined. Yeah, and so you can think of these as happening in sequence. And so first of all, it needs to resolve the imports. Only after it has resolved the imports, it can actually discover all of the options that are available. And only after it has all of the options, it can merge the config for those options. So it knows what this config belongs to, what the type of it is, and so on. And so this is why you cannot depend on config here, because config is only kind of done at a later step. If you were able to do this, it would mean that, so let's say some module.nix defines actually this option in here. So what if we go into some module.nix, and we were to do, actually we don't need the separate file for this. We can do it right in here, like this. So what if this one were to do services.openSSL, we use this as config.enable equals false. And so this is then a bit of a dilemma, because this very module says to not include itself. But then once it's not included anymore, the option would also not be false anymore. And then that's kind of how the infinite recursion can be seen a bit more intuitively. Yeah, but if you actually want to do something like this, what you can do, let's comment this out down here, is use config equals lib.make option mkIf. Well, usually you'd recurse this a bit more. So config equals services.openSSL.enable equals lib.makeIf. So you can see here lib.makeIf config.enable false. Well, I mean, we'd end up kind of in a similar situation. Let's get rid of this. Well, let's leave it here for the history. And so if we try this, that's actually an interesting example. We will actually also end up with infinite recursion, but this is, well, this shouldn't really happen. You don't define enable using itself. That doesn't make a lot of sense. But you can use this for a lot of other things. So we can do lib.makeIf config enable here. And then if that's enabled, we might say something like, oh, extra config. I'm not sure what exists here. Something like this. Yes, this works. And maybe a bit more context here. Why does lib.makeIf work? Because this also kind of refers to itself. We saw how, well, config that's equal to services.openssl.enable, and this is actually config, config.services.openssl.enable. So it's config is defined via config. We saw that this is the kind of local config, and this one is the global one. But still, it's the same thing. And if we tried this in our own module system we just created earlier, we would run into infinite recursion. But so the way this works is that lib.makeIf is not just defined as if this, then this, otherwise an empty attribute set. This is not how lib.makeIf works. Instead, lib.makeIf, we can look at the implementation of it. Well, let's go up here. So it's modules make if equals. So we can see here, it doesn't actually apply the if condition. Instead, it creates this underscore type equals if, and then just propagates the condition for when it's included and the content. And so where this is then evaluated is kind of deeper in the module system. Well, let's first look at Azure. Let's look at that. So type, let's see, where is it? Here it is. So there's this internal function in the module system, which is called push down properties, and that's very accurate. And there's some good description up here, actually. So what it does is it takes these makeifs and pushes them to the lowest level into the attribute sets, and the lists as well, I believe. And so a makeif condition, and then some set turns into this here. So boot equals makeif, services equals makeif. In our example here, what happens is that this here turns into, so this is the kind of the first level, or the original. But this turns into, so this makeif gets propagated one level down, so into here, like this. So now it's under services. Let's simplify this so we don't get too much indentation, like this. So this gets turned into that. That's kind of a desugaring once. And then we can do this again, desugaring twice. So to simplify this a bit, this OpenSSL gets moved over here, and then the extra config ends up like this. And let's do this final time, thrice. Wait, no, that's 3 times extra config. And we end up with a definition like this. So, and this then doesn't cause the infinite recursion anymore, because here we define extra config, but here we access only the .enable. And then at this point, if we go back to the implementation, the type at some point actually then gets evaluated. Here it is, discharge properties. So here it actually checks, oh, if we have a underscore type equals to if, then it's gonna actually evaluate the condition and turn this into either some definitions or no definitions. Yes, so that's how that works. Other causes for infinite recursion. Oh yeah, one common one that's really hard to debug. Let's do infinity 2.nix. Is something like this. So we start again with config. It's really always config because config, that's, we also saw this, that's where the fixed point comes from. Although also options is kind of a superset of config. So you can access all of the config from options directly as well. Maybe just a little bit about this. We have options is a bit mysterious. It's not fully documented what is in there. But so what you have here is, so let's use the example from before again. We have services.openssl.enable, so it has all of the option paths in here. But under these, we do not have the definitions themselves. Instead, it's something like this. We have a value. That's the actual value. That's the same as config.services.openssl.enable. So like this. And then we also have things in here like is defined. So bool whether there's any definition at all. We have, let me see, I think there's definitions where you can access all of the definitions directly. There's also files where you can see where the options are, where the options are defined. I believe you also have LOC, some other things. These two are probably the main used ones. And so from this, you can see you can access all of the config from options as well, plus a bit more information. All right, but that's a side note. A case for infinite recursion is so the cause is mkMerge. And how to demonstrate this? Let me see. We might be able to do mkMerge here. So mkMerge is it also requires a bit of background, I think. So usually you can, well, there's kind of two ways to have multiple definitions in a single module. For one, you can just create more modules. You can do an imports here, and so you can say, okay, I want A to be equals to 10. And actually, let's make this a proper option. So let's use environment.system packages. Then in one case, we might have a hello, packages.hello. And in another definition, we might have maybe some other condition like lib. It could be anything. But we just have two definitions of this, and we want them to get merged. This is one way of doing it, but oftentimes this is a bit overkill to create like separate modules only for this. So something you can do instead is to use lib.mkMerge, and this allows you to just have multiple definitions right in here. So you can say, you can make this option specific. So you have environment.system packages equals lib.mkMerge. And here you can say, okay, one definition is a list of packages.hello. Another one is a packages.openSSL. It's a bit confusing here because we have two times like a nested list. Maybe another example, let's use the OpenSSL services.openssl.enable example. lib.mkMerge here, we could have false, and we could have lib.makeForce true. So this is fairly pointless here because we know it's always going to be true if you make force and don't make force here. But just to show what lib.mkMerge can do, this is as if you had these two definitions in separate modules. Yeah, but this can cause problems So let's revert back a bit. Let's comment this out. And let's say we have an option here. So we have some option definitions. My option equals lib.make option. So we have a type, let's say we have a list. So lib.types.list of, and then maybe let's do integers. Let's say we have my open ports. So we specify here all the ports we want to open, and it's kind of a convenience option for not having to type the longer name. So lib.types.port, that let's say need type to, that's restricted to a port. Yeah, I think that exists. So let's also say default equals empty list. And the implementation, so we're going to use lib.mkMerge. Let's just use this for demonstration purposes. And we're going to do, well, we want to map over all of these open ports and create an option for each of them. So lib.mkMerge, we want to have this list here. Well, we don't need the list itself. We need something like a map port. For each port, we are then going to specify some configuration. And then we're going to do config.myOpenPorts. All right, so here is again the global config. This is the local one. And in here, then we're going to do the longer version. We're going to do networking dot firewall dot open or allowed TCP ports, look like this. And we're just going to say, okay, this is this one port. We might also have, like this might be a list of services, and we might have a submodule here which specifies a port for each service, something like that. All right, but now let's see if this actually works. So let's do Nix instantiate. Attribute config.services already defined. Where is this? Oh, we need to change the file. It's Infinity2 now. And we have a syntax error. That's right here. Oh, no. Oh, no, it is right here. Forgot the closing parentheses. And lib is not defined. Let me add this. All right, we get infinite recursion. And so what is the problem here? Well, by the way, sometimes you can get a bit more information with show trace to debug infinite recursion. If we go in here, so there's a lot of noise. And actually, this is really big, this font here. Let me try it's a bit smaller. So there's a lot of noise, but there is some useful information. So well, we have config here. Let's scroll a bit up here. Let's try to find something useful. Actually, there's not a lot of useful information here. Oh, no, no, there isn't, to be honest, in this case. So sometimes you want to look out for these a bit smaller messages. And so there is code in Nix packages which is supposed to show you the list of options that caused the infinite recursion. And so you might see, oh, while evaluating this option, the infinite recursion happened. And there's some issues in Nix packages, in Nix to improve error messages like this, because all of this noise, the kind of automatically created error locations aren't that helpful oftentimes. And the manually created error messages are often more useful. Oh, and I guess just to show how this can be done, you have this built-ins dot add error context. Yes, this allows you to add more context to the trace messages. So you could say here, while evaluating 1 plus 1, and then we do 1 plus 1 here, but let's add an error. So we do a throw 1 instead. Now, once this evaluates, well, here actually you can't see the trace seemingly. So let's do a Nix instantiate instead, eval an expression, and show trace. And now we can see the extra trace here while evaluating 1 + 1. This does get interleaved with the other traces by default, but yeah, so these are manually created error messages, and you can print anything here. Yeah. So going back to this, we have this infinite recursion here, and it's not super obvious why it happens and how it could be resolved. I'm just going to tell you how to resolve it. So what needs to be done is to move the mkMerge towards the edges of the definitions, or at least far enough for it to not cause the recursion anymore. And so in here, what we need to do is to move the networking.firewall.allowed TCP ports here. Maybe also firewall. Yeah, actually, this should work already. I think we should be able to do this. Let's try it. And failed assertions, well, that's good. It didn't give an infinite recursion. But yeah, I can't, not entirely sure right now why exactly this happens. Oh, we have a comment that you can apparently enable traces in the REPL as well. Let's try this. So currently this doesn't work, but TE showing error traces, very nice. And now we get the trace. Awesome, thanks for mentioning this. Oh, it is here, nice. Yeah, but so just watch out for mkMerge. It can cause infinite recursion a bit more easily. And this is a bit.
I understand it doesn't desugar as good. I mean, it doesn't desugar its arguments, right? So like, it cannot do this automatically, basically, because its argument depends on the config itself. So you immediately get this recursion.
Oh yeah, that's true. Yes. So right, to even evaluate the list here, like even how long the list even is, it needs to know the config.myopenports here. And well, it can't know this because if we have this in here, well, just to demonstrate intuitively, networking.firewall. In here, we could also have myopenports equals something. And so, yeah, it cannot know the value of this option before actually going into here and evaluating this. The mkIf trick doesn't work because, right, even the list itself, the length of the list, can be evaluated. Yeah, and so this is a bit annoying though, because sometimes you do want this to kind of make it more convenient. So you might have a lot of different options in here. You might have services sys.systemd, some systemd, my service, and so on. And then you can't directly do this because, right, it ends up, the services doesn't need to be under systemd. And there isn't really a super good way to work around this. The thing that works is to just duplicate this essentially. So to say, okay, in one we have services, then .systemd, and in the other one we have the firewall one. And I guess you can improve this a little bit by saying, well, we might be able to do something like config equals let. And then the it doesn't really work that well. But yeah, this works, and we can set multiple things in a single evaluation like this. Assertions again. Yeah, but we are just about out of time. Yeah, and so thanks for joining. If you have any questions, feel free to open an issue in the Nix Hour repository. And yeah, see you next week.